students, welcome back to a new mathematics program for grade 8. Today we're going to talk about algebraic terms. This video is the second part of this chapter. Remember that in the first part you learned how to find LCM of algebraic terms. In this program you're going to learn about algebraic fractions, multiplication and division of algebraic fractions. But first of all, let's begin with the definition of algebraic fractions. Algebraic fractions are fractions containing algebraic terms in numerators or denominators or in both. For example, 3a over 5. As you can see here, we have an algebraic term in the numerator. The second one, 3 over a, the algebraic term is in the denominator. Here again we have an algebraic fraction with algebraic terms in the numerator. Now look at this one, m over 5n. We have algebraic terms in both numerator and denominator. These are other algebraic fractions. Remember that an algebraic fraction is a fraction containing an algebraic term either in the numerator or denominator or in both numerator and denominator. Let's see how to simplify algebraic fractions. First, let's see how an algebraic fraction can be reduced to its lowest term. Suppose we have 3a over 6a. To reduce this fraction in its lowest term, first we write both the numerator and the denominator in expanded form. Then we see what are the common terms that are cancelled. So we end up with 1 over 2. Another example, 4xy over 10y. We write both the numerator and the denominator in expanded form. Then we cancel the common terms, 1 from the numerator and 1 from the denominator. Here you can see that 2 get cancelled and y. Can you tell me what is the answer here? In the numerator we have 2 times x and in the denominator we have 5. Yes, it is 2x over 5. Another example, 24ab cube as numerator and 30a square b square as denominator. We write them in expanded form, then cancel out all common terms from numerator and denominator. After cancelling the terms, the common terms from numerators and denominators, here we are left with 2 times 2 times b in the numerator and 5 times a in the denominator. So 2 times 2 is 4, times b is 4b, and in the denominator 5 times a is 5a. Another example, we write them in expanded form, the numerator and the denominator, then cancel out the common elements from the numerator and denominator. The answer here is 2xy square over 5. As you can see, in the numerator you are left with 2 times x times y, and in the denominator 5. Now I'm going to show to you how to multiply algebraic terms. Example 1, 3a over 4 times 5b over 2. As you know, when we multiply two fractions, we multiply the numerators, then the denominators. We cannot multiply a numerator with a denominator or a denominator with a numerator. We need to multiply the numerators. Like here we have, in the first fraction, the numerator is 3a. In the second fraction, the numerator is 5b. So you're going to multiply 3a with 5b, Then in the denominator of the first fraction, it is 4, and the denominator of the second fraction is 2. So you're going to multiply 4 by 2. So we have an answer of 15ab over 8. 15ab because 3a times 5b is 15ab, and 4 times 2 is 8. Another example, here again, you're going to multiply the numerators, then the denominators. 3m times 5n is 15mn, and x times 2 is 2x. Let's see another example on multiplication of algebraic terms. pq over 5 times 5q over 2p. You can see that in both fractions we have some common terms. So since we have common terms, we are going to write them in expanded form first. Then we see what are the common elements that can be cancelled out. Here we have p in the numerator and p in the denominator. Okay, we also have 5 in the numerator and the denominator. We are left with q times q, which is q squared, and in the denominator we have 2. But D, the fourth example, 2a power 3b over 5c times 5ab squared over 2a squared c. As you can see here, there are common terms in numerators and denominators. So we write them in expanded form and find the common factors that can be cancelled out. Okay, so here you are left with a times b times b times b in the numerator and c times c in the denominator. So the final answer is a squared b cubed over c squared. Now we're going to perform the multiplication of algebraic fractions using laws of indices. Students, remember that in grade 7 you learn about indices and the different laws associated with indices. Here we're going to use multiplication law and division law of indices. Let's see how to use these two laws in multiplying two algebraic fractions. The first example, 2a power 3b over 5c multiplied by 5ab squared over 2a squared c. When multiplying the two numerators, you will see that we have a in both numerators, and we also have b in both numerators. According to multiplication law of indices, we need to add the powers. So we have 2 times 5, a power 3 plus 1. Using multiplication law of indices, we are adding the powers of a, then the powers of b. In the denominator, we have c in the first fraction and c in the second fraction. So performing multiplication using multiplication laws of indices, we are going to add 1 to 1, because in the first fraction you have c power 1 and in the second one c power 1. Although it's not written c power 1, you know that whenever we write an algebraic terms, if there is no power, it means that the power is 1. So simplifying the numerator and the denominator, we have 10 a power 4 b power 3 over 10 a power 2 c power 2. Now we have letter a in both numerator and denominator. So we are going to use division law of indices. Remember that division law of indices mean whenever you have the same base performing a division, you need to subtract the powers. So we subtract 2 from 4. Also here there is the number 10, which is common to both numerator and denominator. So we can first cancel the 10, then we perform the subtraction from the powers using division law to end up with a squared b cubed over c squared. let's have a look at another example using multiplication law and division law of indices. Okay, so we perform the multiplication, but in the numerator you don't have same elements. We have x in the first fraction in the numerator, but we don't have x in the numerator of the second fraction. So here there is no multiplication law in the numerator or multiplication law in the denominator. We have x in the numerator and denominator, so we are going to perform division law. But first, let's have a look at the integer values. Concerning the integer values, we can divide by 2. Then, using division law, you're going to subtract 1 from 3. Then, concerning y, 4 minus 3 as power, because in the numerator you have y power 4 and in the denominator you have y power 3. So, performing division law of indices, you're going to subtract 3 from 4. Same for m and n. So the final answer is 1/3 x squared y power 1 m power 2 n power 3. Of course, the y power 1, you can just write y. Now I'm going to show to you how to perform division of algebraic terms, more specifically algebraic fractions. Here the first example is 3a over 4 divided by 5b over 2. Students, you're going to use the same rules for division of fractions that you have done in grade 7. That is, to divide two fractions, you're going to change the division into multiplication by taking the reciprocal of the second fraction. Here also, to perform this division, first we are going to write the first fraction, then we change the division into multiplication by taking the reciprocal of the second fraction. So 5b over 2 becomes 2 over 5b. Now we're going to multiply these two algebraic fractions. So we're going to multiply the numerator first, then the denominator. We have 3a times 2, which is 6a. Then 4 times 5b, we have 20b. Looking at the integer values, 6 and 20, we can divide them by 2. So we have a final answer as 3a over 10b. Let's have a look at another example on division of algebraic fractions. We have 3xy over 5 divided by 2xy squared over 25. So we are going to first write the first fraction, then change the division into multiplication by taking the reciprocal of the second fraction. As you can see here, we have common terms in numerators and denominators. So first we are going to write the multiplication in expanded form. We're going to take the numerators and the denominators in expanded form. Then look at the common terms that can be cancelled out. So we have cancelled x and y. We can also divide 5 and 25 by 5. So we end up with 15 over 2y, because in the numerator we are left with 3 times 5, and in the denominator 2 times y. So the final answer here is 15 over 2y. Another example. Again, we're going to change the division into multiplication by taking the reciprocal of the second fraction. Since we have common terms in numerators and denominators, we're going to write them in expanded form, then cancel out the common terms. For the integer values, we have divided by 2, and the algebraic terms, we have cancelled out the common terms from the numerator and denominator. we are left with 2bm in the numerator and a times n in the denominator. So we have an squared. The final answer is 2bm over an squared. Now we are going to use laws of indices to perform division of algebraic fractions. The first example, 2a power 3 b power 4 over 5c cubed divided by 5ab squared over 2a squared c power 5. The first step is to change the division into multiplication by taking the reciprocal of the second fraction. So here we are left with multiplication of two algebraic fractions. So we're going to use multiplication law first in the numerator. Simplifying them, you're going to have 4a power 5 b power 4 c power 5 over 25 a power 1 b power 2 c power 3. Since we have common terms in numerator and denominator, now we're going to perform this division using division law of indices. Remember that division law of indices means having the same base, you're going to subtract the powers. So we have 4a power 5 minus 1, b power 4 minus 2, c power 5 minus 3 over 25. Simplifying the numerator, we are left with 4a power 4, b power 2, c power 2 over 25. One more example. 6a power 3 b power 4 over m power 3 n power 5 divided by 2a power 2 b power 2 over m squared n cubed. So first we change the division into multiplication by taking the reciprocal of the second fraction. Then we try to use laws of indices, but since we don't have common terms in the numerator and also in the denominator, here there is no multiplication law of indices, but we have common terms in numerator and denominator. Here we're going to perform division law, and also the integer value, we have 6 over 2, which is of course 3. Then simplifying the answer, we will be left with 3a b power 2, m power minus 1, n power minus 2. Now we are going to use another law of indices, which is negative index. M power minus 1 is same as 1 over m, and n power minus 2 is same as 1 over n power 2. So we can write the final answer as 3a b power 2 over m n squared. One more example on division of algebraic fractions using laws of indices. We're going to write the first fraction, then change the division into multiplication by taking the reciprocal of the second fraction. If there is no multiplication law, we use division law. So the final answer here is half x squared y power 2 p power 1 q power 1. Of course, p power 1 q power 1, you can leave it as p times q. So students, now I'm going to give you some exercises for practice. Of course, if you have any difficulties, you can seek the help of your teachers or parents. If you want to have some more information on this chapter, you can log on these websites. Students, in this video, you have learned how to reduce an algebraic fraction in its lowest term, then how to multiply and divide algebraic fractions. So students, this video ends here. Remember that this video is the second part of the chapter Algebraic Terms. In the first video, we talk about LCM of algebraic terms. In this second video, we have talked about algebraic fractions, multiplication and division of algebraic fractions. In the next video, in the last part, we are going to talk about addition and subtraction of algebraic fractions. Till then, goodbye.